Good afternoon to all of you. Myself, M. Soundararajan, Assistant Professor from Department of Agriculture Engineering at Sri Shanmugha College of Engineering and Technology, Autonomous. So, I came with a new topic. In previous lectures, we have discussed about the measurement of rainfall as well as measurement of evaporation. So, in today's lecture, we're going to see that measurement of infiltration. We're going to see the definitions of infiltration, the methods and instruments used for infiltrations, and its application on the real time. So these are the contents we're going to see in today's lectures. Okay, we can move to next slide. So first, we're going to see the definition for the infiltration. It says infiltration is the process by which water enters the soil surface and moves downward through the soil profile under the influence of gravity and capillary forces. So it's a key component of hydrological cycle like evaporation and rainfall. Infiltration determines the amount of water available for the groundwater research and plant growth. So the importance to measure the infiltration is used in it estimates infiltration measurement estimates the groundwater research and helps to determine the irrigation water requirements and reduces the soil surface runoff and soil erosion. When this infiltration increases, soil erosion will decrease in that area. So it assists in flood protection and water management, so helps in design of drainage and irrigation systems. So these are the purpose that is uh, infiltration measurements are used. Then the units for measurement of infiltration is millimeter per hour, then centimeter per hour. So yeah, you given the units millimeter per hour and then centimeter per hour. So hourly we are measuring the infiltration. So it's a job groundwater estimation purpose and irrigation water requirements and runoff and surface runoff soil erosion reduction and assists in flood protection and water state management and helps in design of drainage and irrigation system. So these are the importance of the infiltration system. So already we discussed, I saw that it's a process by which the water enters to the soil by the gravity and capillary forces. So it determines the water available for groundwater and recharge and plant growth. So here you given the picture for understanding. So precipitation occurs above the surface that's shown in the arrow. Then in soil zone, that water enters and then it reaches to the water table. So this one is called what below the water table called saturated zone, and above the water table called unsaturated zone because there is a soil presence. Okay, these arrows are zones that evaporation. Okay, we can move to next slide. So factors affecting infiltration. So the infiltration rate is varies depending on the soil characteristic and environmental conditions. So first one is the soil texture. So if the soil is the sandy has the high sandy particles called sandy soils having high infiltration rate. Then in clay soils having the low infiltration because clay soils having the uh, high water holding capacity, so it reduces the infiltration rate. Then mm it has the fine particles, sand particles having the coarse particles. So soil structure is the another factor affecting the infiltration. So well aggregated soils allow the rapid water movement and compacted soil reduce the infiltration. So initial soil moisture content. So when the soil is dry condition in initial stage, it allows the water to flow into itself. That's why it having the higher initial infiltration rate, and in wet and saturated soil has the low saturation rate because already water is present there, so there is less movement of the water, so that reduces the infiltration rate. Then next is the vegetation cover. So plant roots improve the soil structure, increase the infiltration, and bare and more prone to the runoff. So when the land having the high plant and plant roots that are having the infiltration is high. Then rainfall characteristics. So light rain follows the more infiltration, and intense rainfall may exceed the infiltration capacity, causing the runoff. So a light rainfall allows the more infiltration. So land slope, the gentle slope increase the infiltration. Steep slopes promotes the runoff. So there are the methods measuring infiltration. So double ring infiltrometer and single ring infiltrometer and rainfall simulators are the instruments or methods used to find out the infiltration rate. And here the comparison given between the three methods of infiltration, measuring the infiltration. So, a double ring is the most common method used in field. Then it provides accurate infiltration, then minimize the lateral water movement. Then single ring infiltrometer uses only one ring and which is simpler but less accurate than the double ring infiltrometer due to the lateral flow. So here the double ring infiltrometer minimizes the lateral water movement. That's why it gives the accurate infiltration. So then rainfall simulator it simulates the natural rainfall used for research on infiltration and runoff. So it's a artificial. We had the application of these methods. The double ring infiltrometer used in field infiltration studies. Then a single ring infiltrometer is used as the preliminary measurements. Then rainfall simulator is in research purpose and watershed studies. So for double ring infiltrometers taken for detailed study because it's widely used. So it consists of concentric metal rings driven into soil. So it's a double ring infiltrometer consists of concentric metal. You can see the pictures while I'm telling the theory. Metal rings driven into the soil. So this portion is into the soil. The height is 15 centimeter into the soil. The 15 centimeter bottom portion of that double ring infiltrometer inserted in the subsurface. So components inner ring, outer ring, water supply and measuring scale. So this is the measuring scale and it's the outer ring, it's the inner ring. These are the components. So first we have to insert the ring vertically into the soil for up to 10 to 15 centimeter deep, and we have to fill the rings with the water in same level. So we have to fill this both rings, inner and outer ring, in the same level of water. Maintain the constant water depth. So always you have to keep the water depth in constant level without varying to avoid varying. Then measure the drop in water level in the inner ring at a regular interval. So we have to measure the inner ring water level by help of the ruler for recording the water ruler. So we have to calculate the infiltration rate. Then the advantages of this the accuracy and minimize the lateral flow. So it's widely used in agriculture and hydrological studies. So it's a time-consuming process and a small test area. Right? It's only for small area. So these are the limitation of the double ring infiltrometer. So infiltration curve and application. So based on the values we taken in the field, we going to plot the curve. So that is called infiltration curve. At the beginning, infiltration is high because soil is at the dry condition initial stage. As the soil becomes wetter, infiltration will decrease. You can see the curve line will go downward. Eventually, it reaches the constant value and called final infiltration gap. So this is the constant value. There is no deviation in that curve and value. So that is why it finally reaches the final constant value that is called final infiltration capacity, the capacity of the infiltration of the soil. So typical infiltration curve x-axis shows the time in minutes, and then we using the millimeter per hour for the taken as the unit for the infiltration, but in the curve we using the time in taken in the minutes, and observed filtration is in millimeter centimeter per minute, okay, or millimeter. So in this picture shows that centimeter, but we can also plot the curve take with time and infiltration. Infiltration can be in the unit of millimeter also, but it is in that centimeter, okay. We can plot the take the readings in millimeter also, okay, millimeter also. So the curve shows the rapid decrease in initially, then flow by the gradual stabilization, gradually decrease and stabilized in line. Then the application of this irrigation data is in irrigation system design and groundwater recharge estimation, flood and runoff prediction purpose, and solid water conservation planning, watershed management, and drainage design. These are the applications of the infiltration data. So based on this infiltration data, we're going to do these following uh, actions and planning and decision process. I hope you understood the today's concept about the infiltration and its instruments used to find out the infiltration rate, and common most used method of the double ring method. Then factors affecting the infiltration rate. Definition for the infiltration. These are the concepts we have seen in the today's class. I hope you understood the concepts. We can meet in next class. Thank you.